In this video, we are going to revisit unordered maps. So in the last video, I went over and talked about the difference between the tree implementation of a map versus the hash table implementation of the map, which is called an unordered map in C++. To use these, they are interchangeable, and you can just use them as is. And you can try them out, and you can apply them to problems. But you must be wondering, like, why would anyone ever use a map if we know that an unordered map is so much more efficient? So we know this is log n, and we also now, because we have covered AVL trees and other balancing tree techniques, we know that it's possible to add balancing techniques to binary search trees so that we know that they actually provide log n performance, right? And then we have our hash table implementation, and so you might be wondering, why would we ever use a map when there's an unordered map? Well, it turns out that it's not straightforward to write hash functions, and there's tons of people working on writing general hash functions and hash functions that can work across different types and be implemented into languages, but they're not perfect. And I don't mean that in the term of a perfect hash that we talked about last week. I just mean they can cause a lot of collisions, and those collisions can reduce the unordered map to basically as good as a map, or sometimes worse. And so in order to be able to use an unordered map, you would need to do some analysis on your code to really understand how efficient it is and how many collisions it has. And it wouldn't be too hard to do that, but you would need to do that in order to guarantee its performance, especially if you're using one of the built-in hash functions within the unordered map. So I wanted to make sure that you had some template code on how to actually call the unordered map with a custom hash function, because again, I hope you're kind of seeing this a couple different times through using C++, but one of the ways C++ is general is it allows you to pass functions into other functions, and we've talked about lambda functions and function objects, which are called functors, which allow you to do that basically. And so that's how the unordered map can receive a hash function. So this third input of the type of the unordered map is the functor. So a functor is a function object. I think we've talked about it a couple times, and this is what a function object looks like. It's basically a object or a class that is used just to define a function. So you set up a whole object, but the only purpose of the object is to define a function that you can then pass in to another function or into the constructor of this other object for the unordered map. So that's how you can actually set up your own hash function when using the hash map or the unordered map. And it's a nice thing to play around with and kind of look at what the difference is. In the last video, I showed you just on a really simple case, 3 different types of maps and hash functions and how they perform. And so as you work on the last couple projects in this class, we will be using maps, and I encourage you to play around with some of the different types and see how they perform against each other. In general, if you're solving a problem and you're trying to state the complexity, it would be appropriate to say that you're going to use a hash map and make the assumption that the hash map has O1 complexity, but just know that that isn't necessarily a straightforward exercise, right? Like, it's not just a matter of using a library function. It could involve more work, like writing a custom hash function or choosing the right hash function. So that's all I wanted to talk about with unordered maps. I wanted to make sure you had this template code on how to call one, and you can put the functor within the class that you're writing, or there's a couple other ways that you can set up the code to actually have access to the functor. And I'm actually going to show you another example of this when we go over priority queues. They also need to receive a function object. So you'll see it again when we go over priority queues. And otherwise you've seen it for sort. And I think there was one other case where we used it, but I'm not remembering it right now. So that's it for unordered maps revisited.